in Gdańsk, Poland, and I am opposite to probably most of you. I am not the RTL guy. I am the software guy with very long 27 years of the experience in the networking, and I want to show you or present you the possibility to how we can use the FPGA for the guys like you, and also to improve the productivity and improve the in the creating of the FPGAs, and it is. My daily job is to work with the customers, with the who are the network or the telecom customers who wants to use the FPGAs, and I will focus in this presentation on how we are working and how we can address the problems, real problems of the customers, on base of the some funny story, what can happen in the nearest future, we hope. It is why the name of this presentation is the fastest way to reach Mars, yes, and to communicate Mars. Okay. Let me just go to the let me introduce. I want to talk about the way about the high-level synthesis language, new language, which was called the P4, which P4 stands the Programming Protocol Independent Packet Processor language, which is the in the RTL language, who RTL guys or the FPGA guys understands. It is the high-level synthesis language, which is helping people to define network design or the network pipelines, which could be implemented different way using the different hardware or the different targets, using a switch, NIC, router, or the network function appliance. That I will talk more about the P4. The first of all, as I don't know that your background, if my background is the networking background. I am the software networking guy who is working with the hardware not very long. I started my journey with the hardware with 3 years ago, and I want to first explain you that what is the data plane problem, what we're trying to solve using the P4. Next, to make you very, very short introduction to the P4, and next to show you how looks like the process of the transferring of the P4 to the FPGA, and at the end to present you some practical way how you can use P4 for the programming FPGA without any knowledge of the RTL and any knowledge of time problems like the time closure, number of the gates, feasibility of the solution what you're creating with the real hardware, and how you can test your real design very quickly, and how you can prepare the design. It is that some example how we can enabling or enhance the hardware developer community around the world for the guys who knows only how the way networks, way pipeline should looks like, and they want to use FPGA to improve it. Okay, and the first, let's go to the problem. Imagine that you are in a home. I know that in the COVID time, you probably are in your home and you have a friend in the Mars, yes, and you want to communicate from your home with your with your friends, which is located in the Mars. Yes, you know that your friend has the IP address, which is somewhere in the Mars. Your friend is connected to the internet, and what happens and how this communication happens. Yes, between you are being in the home, you are connecting. You have the Wi-Fi from your probably home router, which is connected through the fiber link to some telecom infrastructure, and this telecom infrastructure connects your home router with the device which is called the BNG, BNG stands for the Border Network Gateway, and this BNG device inside of the operator's site in this big building, normally in the city centers, they are connected to you with the internet. Yes. What is the BNG? The BNG is the device who allows operator, first of all, to authenticate you, to who connecting your connection, your fiber from home to the internet, on base of the IP location, that it is, of course, the limits your traffic, because you can have the more friends, more people who wants to talk with this guy in the Mars. Yes, so you can't choose all the bandwidth for him, and also that inside of the BNG he can prioritize your traffic, for example, your voice traffic, when you are making some conversation with your friend over there. For example, you're presenting exchanging the photos between you and your friend in the Mars. Yes. So it is just the main function of the BNG, what the BNG is doing. And also that how the BNG looks like from the network perspective. That this is that example of the BNG pipeline. It is real pipeline which is used by some operators. When this pipeline, this device implements really the two pipelines. I understand the pipeline as the some set of the tables of the checks what are doing on the packet, because the communication between you and your friend on the Mars is going over using the packets. And the first of all, you're receiving the packets. The next, your packet is the classify, and the classification is the something like the it is the voice packet or it is just the data packet. And next, your packet is going to the policer, so operator checks if you're sent too much traffic or not. If it's too much traffic, you are limited. And the last stage is the routing, when, for example, operator decides, okay, you want to talk with your friend in the Mars, so you're putting a packet to the interface which indicates which is the closest to the Mars, yes, somewhere in the internet, yes. It is that looks like from your point of view when your friend responds, because in the network you are talking about the session, it is the bidirectional communication. It is very similar. The most important is to check if it is the voice packet or the data packet, and you're making the classification. And it is that when it is the voice packet are put before the data packets, and this packet is going to your fiber, so you can communicate freely, or you can make the conversation between you and your friend in the Mars. It is just just a simple example how the pipeline is defined, and all the blocks of this pipeline could be represented in the network as some match action tables programmed by the operator, and some operation related to this result of this match action table. I will talk a bit more about this one in the future. How we can implement this BNG pipeline. The first way how we can do this one is software, is the pure software implementation. Yes, you can get a server, you can get the card, NIC card, network interface card, and connecting and you can make the processing inside of the software. And this is that simplest way of the building this one, and many people are doing this one because it provides the flexibility. But some people wants to use the FPGA, and here the FPGA happens when we can have the software plus the FPGA, and we can put some parts of the pipeline and the FPGA. And for the BNG case, it is very often the most often used case is the traffic manager, which is used or implemented inside of the hardware. This traffic manager is a block responsible for the putting of the packets that in the different priority, with the highest priority first and the lowest priority at the end. That also you could think about the very, very efficient implementation when you have the Intel Tofino switch, for example, connected with the FPGA, who also can make the similar operation, but much under much higher speeds. And all in this case, the FPGA is just a solution which should be programmed and connected to the system, and when your software should be communicate. And also this FPGA is designed which should, and all this communication process, all this this way of the communication we call the protocol handling. This protocol handling could be implemented inside of the FPGA, and we can use for this one P4. Yes. Let me just talk a bit what is the difference and why we are talking about the different implementation. Yes, and some of the presentation today, I saw the presentation that the people presented the difference between the ASIC and the FPGA, and I don't want to repeat this one. And mostly the CPU is considered to have the very general solution. We can do everything in the software. It has a very good productivity. It is very easy to do the software, very easy to debug. And on the opposite side, you have the ASIC, which is not so general. It solves the one problem, but it do it very, very efficiently. But creating of the ASIC software, ASIC hardware is the very time-consuming process and very expensive process. But really, the ASICs has the best performance. Yes, we're talking about the ASIC has the best performance to watt factor. And in the middle, as the golden mean, we have the FPGA, yes, which is the very, very general solution, which you can implement many things inside of the FPGA. It can improve the performance of the software, and also, but the one of the bottleneck is the similar as to all the problems what we have together with the hardware. We have we want to improve the productivity. How to create the image for the FPGA. Yes, as the hardware engineers, you know that it is not so simple, and for many people, the barrier, for example, moving from the software to the hardware is the barrier which nobody can jump. Yes, it is just to, when you start your career, you probably should define, yes, that I will be software guy or will be hardware guy. So that it is that very, very big difference, yes, especially in the thinking. Yes, it is why is the place for the P4 here. Yes, that how to improve this one. And what is the P4? That P4, as I said, stands for the Programming Protocol Independent Packet Processor Language. The people, it was created 5 years ago, somewhere in the Stanford or Princeton, I don't remember. And people just wanted to define a problem of the networking pipeline using some in the way that it could be the first of all the protocol independent. You know that we have the thousands of the protocols, and the people are the very creative. The network guys are the very, very creative. So we will have the job for years to implement, to making sure that the implementations or what they need to be work efficiently on the hardware. It will take years to implement everything. So that from the networking point of view, if you're working in the networking, your job will never end. Yes, so it is good. It is good time for us to implement. Yes, and the P4 is the language when this network guys can implement and can show us what they want to achieve. Yes, with this one, how this packet should be processed. Yes. And additional advantage of the future of the P4 language is that it is the target independent. Yes, it is the P4 is just a language which do not say nothing what will be the final implementation. Yes, for example, even when you are programming the CPUs, yes, you are written in the C, yes, that the C is the target independent in that sense. But for example, the assembler, we must have some compiler which compiles you, for example, the C code to the different implementation. Yes, and the same when you are written the code in the Verilog, that the very, very simple designs could be ported to the different architectures, but really it is really that you can do this in the very, very simple design. Yes, and also the and P4 is designed to define design the people who are creating the P4 language, the P4 community, which is located on the p4.org community. They are a very they created a version which makes sure that they care very much to some protocol independence and target independence. Yes, they created, for example, the story of the P4 language is that they create a version of the P4 14, and next they go to the version P4 16 when they removed any places when this target independence was the problem. Yes, so that it is that the language was the rewrite to be sure that it is the target independent, and also the additional thing is the filter configuration. So, as you know, that from the P4, we want to with the P4, the goal of the P4 using the P4 language is to have the same hardware and make the different implementation. It is just that before as I say, the network guys are the very, very creative, and they want to use same hardware to implement different protocols or different ways of the communication. Yes, if the something doesn't work, it is P4 really was created as the language for the trying of the new protocols and new communications. That really the vision of the guys from the P4 who created P4 is that in the near or the far future, you will be able inside of each data center, yes, or maybe inside of each home, you will create own network for you, but own protocols when you will communicate each other, and the P4 will be something which defines some common sense between you and your friends, and thanks to the P4 you will be able to communicate using these different protocols. Yes, of course, this is the song of the future, and it is just some vision of the guys from the academy. Really, it is nice to see the future, but really the reality is that a bit different, and that people wants to use the P4 to efficiently implement current implementation. Yes, and they do not go in reality. They do not go in the future so far as like these guys from academia. Okay, if you can see, for example, how it looks like the P4 language. As I said, the P4 language is the set of the tables. Some people in university, just make a proof, a mathematical proof that the every network behavior, yes, the stateless network behavior could be implemented as the set of the tables. The most important part of the P4 language semantics is the defining of the tables. Some examples you have here on this picture, and you can see, for example, the table which is called routing. The table has a key, which the key is for example, some IP address. The type of the table is the LPM, the largest packet match, so it means that it's some kinds of the TCAM. And you have some actions related to the entries, yes, you can choose, and you have the size of the table, yes, and it is just all the tables, that the definition, yes, it is what you see and how you're creating your design. Of course, this is that very, very simple, but for the guys who are creating, I hope that many of you created many network network devices, yes, or the network pipelines inside of FPGA, that really that creating of the tables inside of the pipeline is really the easiest way to implement the pipeline. Okay, let me just go back to our BNG pipeline. Yes, of course, as I described to you how the BNG pipeline works, the real device which is used by the operator to connect you with your friend in the Mars in both direction, that it is also the pipeline. And when the firewall is just kind of the table, the flow classifier is the name of the table when you are choosing some field in the packets or the protocol and the port, how you are connecting this one, it is additional table. And the policing and the routing is that also table, which is that very similar to this table. When the LPM, it is just, you see that the P4 easiest the implementation, and today many companies, especially the telecom companies, just starts to work using the P4 to define what they want to achieve. Yes, of course, not everything is achievable, but this is that a similar way that when I was learning the VHDL, I just discovered that the VHDL is not only the language for the making the real synthesis, and but we can using the VHDL for the modeling of the some behavior, yes, of the systems, yes, and the same is with the P4. Not all the P4 implementations or the P4 designs are the synthesizable, but you can find the way how to how to make the synthesis of the two. You can create the P4 program which could be synthesizable. Yes, if you are more interested in the P4 and how the P4 is used for the telco, you can use the page like the ONF, to Open Network Foundation, who specialize and really that they target is to create and recreate the current network and show the examples how the telecom networks could be implemented using telecom networks could be recreated using the P4, yes, and that how overall system works in the reality. That also the various company called the Deutsche Telekom, which provided works very actively, and for example, they provided the pipeline of the BNG written in the P4. It is why I use this one, because you can see that this you can find a similar pipeline, how it works in the reality in this page, that how it is how it looks in the real pipeline in real system. Yes. Let me talk more what P4 defines. Yes, the P4 definition is defines, of course, the ports. Yes, you have the input port and you have the output port. because you are talking about the packet, we are talking about the packets, and you are talking about network design. We know that the packet is going over the port, yes, and depending on the port, ingress port or egress port, that you can make different actions, yes, and the number of the port would be the part of the lookup. And inside of the P4 design, you have always you always defines the three main points. The one point is the parser. Yes, if you work the parser. If you work on the networking design in that FPGA, the parser is the way to extracting the protocols of the packet content, of the data content into specific fields, which on the picture called the input headers. These input headers are the input to the match action pipeline. This match action pipeline is the set of the tables what should packet go, or the data from the extracted from the packet should go to defined action. What action could be in the P4? That it could be, for example, the drop. It could be increase the statistics. It could be modify some fields. It could be the decrease, for example, the TTL time to live in the IP header. But the stage is just to for the defining of the action. Yes, the action what is performed on the packet happens inside of the deparser. That the parser of the modifier. It is just to get a packet, extract the packet, and make defined what you should do with this packet, and make this packet modification on the last step. Yes, and put this packet out, which to the next pipeline, which also from the P4 point of view, you can freely define, for example, what is the implementation, yes, how the implementation looks like. Yes, it could be the you can implement part of the pipeline inside of the software using the DPDK. If you are aware of this development kit for the CPUs, or you can spread the half of the in the DPDK and half of the in the FPGA. You are freely to do, yes, freely to do this one. As I said, one of the missing points, yes, what the P4 do not define is the stateful operation. The stateful, like the keeping of the state. There is some concept of the registers, of the counters inside of the P4, but it is not the stateful operation like we can imagine that, for example, the keeping of the state of the TCP session, yes, that the tracking of the TCP sequence number, of the making some, let me say, sequence number based firewalls, that it is unfortunately, in current version P4, it is not defined. That currently we can assume that the P4 is the way to define some stateless pipeline inside of the FPGA. Okay, it is just really that defining that how the DPD how works, how P4 works. And we can go here how we can make to P4 for the FPGA. Yes, that P4, as I said, is the language for high-level synthesis. Yes, it is like, for example, some people can have the OpenCL. There is some possibility in Intel, for example, maybe you heard the one API when you can program inside of using the C++. It is that P4 is the high-level synthesis language which is used for the defining of the networking pipeline. Yes, and what is the promise of the high level of the P4? The promise is the same as the other high level synthesis. Yes, of course, we want to improve engineering productivity. Yes, we want to have the rapid design generation. We want to have accelerated verification and the validation, yes, and we want to have improved the portability between different FPGA families and even between vendors and even between different, it is just what I described you, this target independence. And of course, to me as the non-RTL designer, that enabling not expert network engineering users to use FPGA, yes, to improve, to increase our community of people using the FPGA, to making sure that more people will have the fun with the FPGA. And we have also some same disadvantages or some challenges related to the P4. This is that the one of the problem is achieving the performance and area comparable to hard-coded RTL, and also the providing performance guarantees, which because with the P4 we can generate a code, but we are not and we have a limit. Yes, that of course the P4 guarantee, for example, some defines and how. How we choose what implementation we choose, we can define this one, and it is that something what we're working. And I see the question here that complexity of the overhead. Yes, that related to the complexity and the overhead, that, for example, when we are compare the very, very simple designs, yes, for example, the single table from our P4 compiler, what we are working, the P4 can generate even better source than the some set of the standard libraries of the some standard toolset, because when you have the RTL designer, you have the own toolset of the tools, yes, what you use, what you are proved in your previous work that it works, and we make some simple experiments. It looks like that in some cases the P4 generates, but even the less code than this tool set, yes, which is of course the working, but not very much optimized. But really, we also observe that when we are going into much more complex designs, it is also the complexity works and the handwritten code works better. And our assumption is that if we can achieve the 80% of the 70% of the performance of the RTL written in the scratch from hand, that it will be good success, yes, because that we achieving the something which is also the inside of the P4. We have the blocks which are called the externs, which, for example, the example of the externs is for example, the QoS designs, which are very not possible because they are the very, very stateful, the set of the hierarchical QoS, and we choose the model that we, from the P4 code, we controlling the HQoS, for example, but we implementing the HQoS inside using the RTL. Yes, that it is the something what the way how we can implement that more complex pipeline. Yes, the most important thing is to provide the interfaces, yes, from the P4 code, how this blocks, which are the use or the created in the control by the P4 are communicated with the P4. We normally are using some metadata, which is the standard way how the P4 defines and how that packets goes over the pipeline. It is that the packet plus metadata, and we use modifying this metadata to control these blocks which are the out of the P4 code. Yes. Okay. Okay, right now I want to shortly told you something about the FPGA for network engineers. How the network engineers can use. It is my colleague from Intel just today just make you the description, more detailed description about the card N3000, which is called the FPGA programmable acceleration card, and it is that a good start. It is the card with the Intel Area 10 FPGA and has the 4x25 or 8x10 gig interfaces, and it has the Gen 3 by 2 by Gen 3 by 8 interfaces connected to the PCI. It is the card which you can push us from Intel. It is that you see that description is that it is the kit from Intel, and it is ready to use the card with the security and easy to and well-defined interfaces. Yes, what my team is doing currently in Intel in Poland, in Gdańsk, we're working on the P4 compiler for this card. Yes, that how looks like. I want to show you how looks like that in the simplest way, the way how you use this P4 compiler. Yes, the first of all, you should create your pipeline. Yes, it is in the bottom. You know that it is the BNG pipeline, and you implement this one using the P4. The next step is you checking this pipeline using the open source tools, open source simulators, which is called, for example, behavioral model version 2, BMV2. It is just, and check if this works. That if it's working, you are using the compiler and you generate IP together with the some hand-coded IP. It is just the way, for example, you want to have the HQuos and to implement, for example, this traffic manager, which is the HQuos is looking that we connecting this in that model, this flow classify is implemented in the P4 and it is generated IP, and we connecting this together with the hand-coded IP, which is the traffic manager, which is that HQuos. Yes, and together we have the some RTL. And normally, when you have the expert in the RTL design, you can put this to the any card. But we know that the people has the big problems moving this RTL design together with this RTL design with to the real card, to the real FPGA, because you have the transceivers, you have the RAM access. Yes, you have the RAM lines, you have the PCI lines. Yes, you must to implement some kind of the host interface. Yes, how to access this card. So we, as Intel, we created some BSP or the board support package for the N3000 card, which is available and you can download it after registration from the intel.com. And we connecting in our tools together with the netlist, which is generated by the by this IP. And generated by the P4 compiler, yes. And at the end, we creating the of course, using the constraints what we have inside of the design, and we just creating simple design when we can use the Quartus Prime to generate the bitstream. Yes, the Quartus Prime just making the synthesis, just making the fitting into design. At the end, we get the bitstream, which the people we can get a card. We can use our set of the tools, which is called the OPAE, that the open platform acceleration, OPAE, open platform acceleration environment, and we can put using software tools available from the intel.com to program this card. Yes, and next is the best. You can connect this card to to the server. You can get drivers because we have the inside for the N3000 we have the standard host interface when the drivers, network drivers, are available in every Linux operating system. It is because that you can use for example, the Virtual, or you can use the Intel NIC XL710 as this one, and you can send the packets, and the packet will go out to this gigabit interfaces. Yes, it is just the, let me say, dream, and we assuming here that we're working with many customers who are not knowledge of the FPGA and can use that kind of the operation FPGA that way. Yes, it is what we want to achieve. We want to extend the we want to extend the number of the people who are using the FPGAs. Yes, that without the very deep knowledge of the very deep knowledge of the RTL, yes, and how to create design for the FPGA, yes. Okay, let's make me some very short summary that we want to, with our P4 for FPGA compiler, we can create the FPGA, we can create the bitstream and use that with no Verilog VHDL knowledge, no peanut assignment, with the standard drivers for the management and data plane. We have also with the orchestration, so we enabling possibility to use this card for inside of the data center. It is the card ready for the mass deployment. We have the many vendors who can sell this card inside of a server. It is qualified by these vendors, yes. And we working with the open source front-end compiler and the p4.org, and we can use the same p4 language as is designed by the p4.org. Yes, and I hope some way we'll go to Mars and communicate with this guys on Mars using that FPGA. Thank you very much. It is all what I have today. It's the 5 minutes left for your questions. Any questions you can put also on the Discord. Okay, I got a question. What are the options for output generated by the compiler? With the compiler, we deliver for the user, we deliver the RTL. So the user can look how the RTL is generated, and what we are delivering here. Let me show. And the picture that we have the project which could be, we have two options. Yes, we have the project which could be connected. That one output, what you can see, this generated IP, and another output are this hand-coded IPs. Yes, some hand-coded IP are encrypted by Intel, which so you could get them inside. But what is generated here, you can receiving the really the compiler is do not use the Verilog, it's using the VHDL, so you get the project of the VHDL, and which you can put inside of your BSP. Yes, that it is just the option for the more advanced customers who own the FPGA designs, which can put here and create their own design and own on the card. Yes, by the license, we allowing also from the license. You must agree that you should use only the Intel FPGAs. Yes. It's difficult to answer the question, but it depends from our trials, what we made. It depends on the complexity of the design, yes, how many tables we have and how optimized it is. For the very, very simple design, for example, the single table, and also it depends what is the style of the reading of the code, yes, what are the libraries used for the generating of the code. It is that for the simple designs, we are that P4 compiler generates the less can generate less code than the handwritten, but of course that it is difficult to say that to match very big, let me say, very sophisticated time closure. That it is, we assuming that it is normal for the quarters that if the logic we are going to the logic, which is that I think the 60% of the overall resources that we can get something like that time closure, but really that it depends on it depends how it depends how complex the design is. Yes, so that it is it is difficult to say making such comparison. Yes, because also the fitter also it has the simpler simpler way that it has the simpler work to do. It will better use the gates, yes, or use more gates. Yes, it is that really it is difficult to is difficult to say exactly. Yes, for example, the 50% versus the 60%. Yes, it's the very big dependency and how the fitter and how compiler works and what is around of the overall design. Yes. Okay, I think the times it left. If you want some contact to me, just you can get from Magdalena, yes, and you can have the from this one, yes. Please tell me about the. You can send me an email. My email is miroslaw.walukiewicz@intel.com. And thank you very much. I can answer any of your questions really on the also on this using Discord.
Hi, thank you a lot, Mirek, for your lecture. So Discord would be available still, so you could ask questions also after this lecture is closed. We will leave the Discord open for several hours or even days later.
Okay.
So
thank you very much again.
No one is writing. So Discord is being kept open. Let's get met there. Thank you, everyone.